Hello, my name is Matthew, and I have the privilege of being paid by Ericsson to make the world a better place through open source, and for that, I am grateful. I would like to show a little feature that I'm not sure if one knows about for Trace Compass today, but this is something that comes from the tracer itself. In our case, we are using LTTNG, and we are recording power events. Now you could see that the power events are basically frequency scaling. Why frequency scale? Well, basically, the CPU can announce that it doesn't need, or the scheduler can announce that the CPU doesn't need to be at full power. And I'm going to zoom out now. And I'm going to enlarge the resources view. So these green bars are our frequency bars. And they are violin plots. If you zoom in, you will see that they go up and down. They get wider and thinner depending on how much CPU power is needed. A really cool thing is that your power consumption is typically your voltage squared times frequency times a few other factors, but your frequency and voltage are directly proportional. So you could say that your power consumption is proportional to frequency cubed. Now let's take a look at what this means here. You can measure your power consumption for a given process, but you can also see when your scheduler enters a very strange state. For example, here, this looks very different. You see that you have dips in frequency on 3 of your 4 cores, and one of them is at full speed. Your XORG here is being hammered by these IOCTLs. And all the other cores are running at very low power. So if I were to minimize, then go here, let's take a look at what's going on in one of the IOCTLs. That would be little exploration. Of course, I clicked the one place I shouldn't. Here we go, IOCTL. Let's just look up. This would be an IOCTL. So it's on file descriptor 44. We got to look it up. So then what we can do is look up file descriptor 44 here. And I know that it's normally per thread, but we can do that inference later. Now we can find out what's going on. I'm not going to do it here. I just want to let you think about one future possibility. I would love to see a power-aware critical path analysis. If anyone has the time to be able to do something like that, we will gladly review it, and I think that this could be a really cool feature add for anyone doing power-aware compute. Thank you very much, and I hope that all your problems become shallow when you trace them.